Hi, welcome to Physics 1.1 on terms, units, variables, and equations. This is called Tuve. The objective is to identify every single part of a problem and what that problem deals with. So let's start by looking at the definitions. Distance is the amount of space between two places or things. Displacement is the change in position of an object. So distance is literally how far you go, the number of steps, if you will. But displacement is how far you are from where you started. It's just a change in position. Length is the measurement of an object or space in one dimension. Okay? Speed is the magnitude of the velocity, the travel of a distance over a period of time. Velocity then is the speed in a given direction. Acceleration is the rate of change of velocity. It is speeding up, slowing down, and even turning. Time is actually an undefined quantity, but for our purposes, time is going to be identified as a continued progression of existence. Now let's look at the units for those. Distance, displacement, and length are all measured in meters. Speed and velocity are both measured in meters per second. Time is measured in seconds. And acceleration is measured in meters per second, or the abbreviation sometimes you'll see is meters per second squared. Looking at the variables, there can be multiple variables for given terms. Velocity is represented by v and v naught. Change in velocity is represented by a delta v. That little triangle stands for the word delta. Acceleration is represented by the letter a. Distance is represented by x and x naught for horizontal motion, y and y naught for vertical motion. Displacement is represented by delta x and delta y, because remember, displacement is a change in the location. Delta x or delta y is going to be x minus the x naught. Any of the naught are the initial, where it starts, the starting place, and then the x or the y or the v are the final. Time is represented by the letter t. Naught, again, stands for initial. Delta stands for change in. Now let's look at the equations you're going to be playing with. These are the basic kinematic equations. We will look at them in detail one at a time, so you don't need to rush to get everything written down. Kinematic simple is x is equal to x naught plus vt. Kinematic 1 is v is equal to v naught plus at. Kinematic 2, x is equal to x naught plus v naught t plus 1/2 at squared. And kinematic 3 is v squared is equal to v naught squared plus 2a delta x, or x minus x naught. So here's how your problems will be set up. You will be looking for, in the problem, the terms, the units, and variables, and then potentially the equation that you would use to solve that. So you list what is given in the problem, and you either highlight it or mark it in some way. And again, if you need a highlighter, I have those. And mark it in some way, and then you have to fill in the rest of the chart based on what you know. So here's an example problem. A rectangular field is 100 meters by 50 meters. A man walks the perimeter of his field in 112.2 seconds. At what velocity did he walk? So if you look at the problem, you should notice that you have an m. M is a unit of meters. You have SEC, or S for seconds, unit again, and then you have the word velocity. That's all that you're given in the problem. From that, you have to fill in um, everything else. That would look like this. By filling in the rest of the chart, you can determine what equation you would need to use to solve it. So meters is distance or displacement, seconds is time, and based on what's given, your velocity would be measured in meters per second. The variables that you are looking at, since this is a horizontal field presumably, are x and x naught, t, and v. So the equation we would need to solve this problem is kinematic simple. That's what you're doing with Tuve. The biggest problem for any science class, advanced science, is figuring out what the problem actually says and what equation to use to solve it. We're going to start with these. So I'm going to give you a piece of paper, and if you don't have a colored piece of paper, if you're at home, you don't have a colored piece of paper, I'm going to hopefully be able to get one to you. Otherwise, get a piece of paper and label it formula sheet, okay? You're going to keep your own formula sheet. So in box number 1 on your formula sheet, or make a box for your formula sheet, is kinematic simple. X is the final position, the displacement from the origin, measured in meters. X naught is the initial position, not always the origin, so be very careful, measured in meters. V is the velocity in meters per second, and t is time in seconds. Kinematic 1 is v is equal to v naught plus at. The v is the final velocity in meters per second. The v naught is the initial velocity or the starting velocity in meters per second. A is the acceleration in meters per second, and t is time in seconds. Kinematic 2, x is equal to x naught plus v naught t plus 1/2 at squared, where x is the final position, the displacement from the origin in meters. X naught is the initial position in meters. V naught is the initial velocity in meters per second. T is time in seconds, and A is the acceleration in meters per second. Kinematic 3, v squared is equal to v naught squared plus 2a delta x, or x minus x naught, where v is the final velocity in meters per second. V naught is the initial velocity in meters per second. A is the acceleration in meters per second. X is the final position or displacement from the origin, and x naught is the initial position. Thanks for watching.